Hello and welcome to Nunley Math. I am your host, Aaron Nunley, and I am here to talk to you today about subtracting integers. When you look at the four integer operations, addition, subtraction, multiplication, and division, subtracting of integers is the one that tends to give students the most difficulty on the most consistent basis. But I think I can help you with that today. And so we're going to spend a few minutes talking just about subtraction in general, and then we're going to talk specifically about how we can use our understanding of subtraction along with the number line to develop some rules for subtracting positive and negative numbers. So here we go. There are two ways that people typically think about subtraction. Method number one, the most common method of thinking about subtraction, is what I refer to as takeaway. The story goes something like this back in elementary school. Somebody has 10 frogs. If I take away 3 frogs, how many are left? Or something along those lines. And then, of course, we're going to model that using a subtraction problem that looks like this. 10 take away 3 equals 7. Or 10 minus 3 equals 7. That's the most common way we think about subtraction. But there is another way to think about subtraction. This is method 2, the difference, or sometimes I refer to this as using subtraction for comparison. This story goes something more like this. Arpit has 10 buttons. Rajit has 3 buttons. What's the difference between the number of buttons that Arpit has and the number that Rajit has? Of course, we're going to model this the same way, using subtraction. Well, Arpit has 10, Rajit has 3. That's a difference of 7. A difference of 7. The difference between 10 and 3 is that the 10 is 7 larger or 7 more. I want to think about subtraction this second way today. A lot of teachers teach subtraction of integers using the takeaway method, and there are a lot of very valid ways of doing that, particularly using integer tiles and something they refer to as zero pairs. But I think the number line method, along with thinking of subtraction as differences, is a viable option for a lot of students in terms of trying to make this a little clearer. So let's do this comparison model for subtraction using a number line. And I'm just going to give you a simple subtraction problem to start with, 8 minus 3. And we'll do some more and more challenging problems as we work our way through here. But we'll start with a simple one to kind of illustrate the method. 8 minus 3. Now you could read this as, how does an 8 compare to a 3? Or what's the difference between an 8 and a 3? And of course you know that answer, but the answer really isn't the point. The model is the point. So to help us with that model, I'm going to put up a number line. Notice on a number line, the farther to the right you go, the greater the numbers. So 0, 1, 2, 3, 4, 5, 6, 7, and so on. The farther to the left you go on the number line, the less the value of the numbers. So I'm going to drop an 8 onto my number line. Notice this is 5, 6, 7, 8. And I'm going to put a 3 on my number line. Now, when I look at this and I compare the location of the 8 and the location of the 3, I find that there are 5 spaces that lie between them. 5 spaces that lie between them. Well, that tells me that the 8 is 5 spaces farther to the right, or 5 spaces greater. 8 is 5 greater than 3 because it is 3 spaces further to the right on the number line. So we would say that when someone asks the question, how does an 8 compare to a 3? It is 5 larger because it is 5 spaces to the right. Do you see how that works? The location on the number line not only tells us the distance between the numbers, but it also tells us which one is greater and which one is less. Let's try another one. We'll still keep it fairly simple for you. Consider 10 minus 1. Or, how does a 10 compare to a 1? Or what's the difference between a 10 and a 1? Once again, I'm going to put up my number line. Once again, we're going to identify the location of the 10 on the number line and the location of the 1 on the number line, and we're going to look at the amount of space that lies between them. Notice that between a 10 and a 1 are 9 spaces. In fact, 10 is 9 greater than 1 because it is 9 spaces further to the right. Remember, the numbers that are on the right are larger. So I would indicate my solution as a positive 9. 9 greater. See how that works? Let's make this a little more interesting. How about 4 minus 8? How does a 4 compare to an 8? Or what's the difference between a 4 and an 8 on a number line? Well, my 4 is here, and my 8 is here. That's a difference of 4 spaces. But notice this time, the 4, when compared to the 8, is farther to the left. 4 is less than the 8 is, because it's farther to the left on the number line than the 8 is. Because of this, we would say, oops, wrong direction on my arrows. Because of this, we would say 4 is 4 less than 8 because it is 4 spaces further to the left on the number line. Or my solution to this subtraction problem would be negative 4. When I compare a 4 to an 8, I would say it is 4 smaller. 4 smaller. See how that works? Take a look at this one. 2 minus 9. How does a 2 compare to a 9? Or what's the difference between a 2 and a 9? Here's a number line. I'd recommend you pause the video and try this one on your own, and then restart the video to see if you're doing the same thing that we're doing. I'm going to go ahead and go because I'm going to assume that you've already paused. The 2 is here. The 9 is here. That's a difference of 7 spaces. But notice, the 2 is 7 spaces to the left of the 9. The 2 is going to be smaller than the 9. 2 is 7 less than 9 because it is 7 spaces further to the left. Because it's 7 less than 9, we're going to go ahead and call this a negative 7. It is 7 smaller. Tell you what, here's another one. Try this one on your own. How does a 2 compare to a negative 4? I'm going to assume you've already worked this out on your own. 2 is here. Negative 4 is here. That's a difference of 6 spaces. 6 spaces. Notice that when we're comparing a 2 to a 4, the 2 is larger than a 4. It's larger than a 4. It's farther to the right. So it's going to be 6 spaces further to the right, or positive 6. A 2 is 6 larger than a negative 4. Here's another one for you. How does a 5 compare to a negative 8? 5 is here. Negative 8 is here. That's a difference of 13. Is the 5 larger than or smaller than the negative 8? Well, 5 is 13 more than the negative 8 because it is 13 spaces further to the right on the number line. Since it's 13 more, we would say it is positive 13. How about this one? How does a negative 3 compare to a 4? A negative 3 is here. A 4 is here. There are 7 spaces in between. How does a negative 3 compare to a 4? Well, a negative 3 is 7 less than a 4 because it is 7 spaces further to the left on the number line. Since it's less than 4, we would call it a negative 7. I got one more for us to do together. Once again, I would recommend pausing and trying on your own and then watching the video. I'm going to keep going. A negative 1 minus negative 10 asks, how does a negative 1 compare to a negative 10? Or, what's the difference between a negative 1 and a negative 10? Well, negative 1 is here. Negative 10 is here. That's a difference of 9 spaces. But the negative 1 is larger than the negative 10. Since negative 1 is 9 greater than negative 10, and it is 9 spaces further to the right, this is a positive 9. Tell you what, I've got 5 more for you to practice on your own. I'd recommend trying all 5 and then coming back and watching the video. Now that you're back, I'm going to go ahead and tell you the solutions to these. This one's a 10. This one's a 5. This one's a negative 8. This one's a negative 9. And this one is a 0. I'm not going to go through and do every one of those on the number line. If you're still unclear on how the number line helps, you can certainly go ahead and rewind the video and watch this again. But ideally, we want to get to the point where we can do these mentally. I want to be able to look at this and say, oh, I can think of where negative 7 is, and I can think of where a positive 2 is, and then I can figure out in my head that there's 9 spaces between them and that the negative 7 is smaller. Ideally, that's where we want to get. Although, once we get good at that, the truth is almost nobody actually does this method. Now, this is the logical premise, the mathematical premise behind our subtraction rules, but honestly, very, very few people will do subtraction this way in Algebra 1. Notice on this screen, I've listed all the subtraction problems that we just did. But someone much smarter than me noticed something. They noticed that if I were to do 8 plus negative 3, what would my result be? Well, they realized that was a 5. And then someone realized, hey, wait a second. 8 minus 3 and 8 plus negative 3 both have the same solution. They both have a solution of 5. And then they decided, let's try something else here. 10 minus 1 is 9, but 10 plus negative 1 is what? It's a 9 as well. 4 minus 8 is negative 4, but 4 plus negative 8 is also a negative 4. 2 minus 9 is a negative 7, but what's 2 plus negative 9? It's also negative 7. 2 minus negative 4 is a 6, but 2 plus positive 4 is a 6 as well. Are you noticing anything interesting here? In my example, the first number always stays the same. But notice, instead of subtraction, I'm doing addition. In fact, I'm adding the additive inverse or the opposite of this second number. Instead of doing a minus 3, I'm doing plus negative 3. Instead of subtracting a 1, I'm adding the opposite of 1, or negative 1. Instead of subtracting an 8, I'm adding a negative 8. Instead of subtracting a 9, I'm adding a negative 9. And instead of subtracting negative 4, I'm adding a positive 4. And when I do that, when I add the opposite of this second number, I'm always getting the same result. You see, this subtraction rule that we've been working on is actually a lot to think about. It's a lot to keep straight in our head, and honestly, if we have to draw the number line every single time, it becomes very long. It becomes a very arduous process. We may not have a number line. It's also fairly difficult if we have to deal with numbers that don't fit nicely and neatly on a tiny little number line like we had that only goes from negative 12 to positive 12 or so. So instead of doing subtraction, Very, very few mathematicians will actually do that. Instead, they will do the equivalent addition problem. They're not going to do minus 3. They're going to rewrite the problem as plus negative 3 and work it out. So when I come down here and I say 5 minus negative 8 equals 13, instead of 5 minus negative 8, what do you think most mathematicians are going to do? They're going to do 5 plus 8 and get a 13. Instead of negative 3 minus 4, most mathematicians are going to rewrite this as what? Negative 3 plus negative 4, and they're going to get a negative 7. Instead of negative 1 minus negative 10, most mathematicians are going to solve negative 1 plus positive 10 and get a 9. Take a second, see if you can rewrite the rest of these. I'm just going to click through them very quickly, assuming that you've already worked them out while the video was paused. Here's what we're going to do. Our rule for subtracting integers is this. Don't. Nobody subtracts integers. Instead, you want to add the opposite of the second number, or change your subtraction to addition and change the sign on the second number. By the way, this one here works out the same way, and notice that it does become a 0. Now, if you are in my class and you're going to be doing this, this is what this is going to look like. Let's see if I can get a pen here. I'm going to be giving you problems like negative 3 minus negative 2. And my expectation is going to be that instead of solving this, you are going to rewrite this underneath and change this minus to a plus and change this negative 2 to a positive 2. Because negative 3 plus 2, we all know how to do from our addition rules. That's a negative 1. If you're not sure on your addition rules, you may need to go back and do that again. Now, students always ask me, can I just come through and do some scribbling in here? In some of the classes, they teach a plus positive technique. We are not going to do that. We're going to physically rewrite this underneath on our paper and then simplify. Long term, you're going to find that's going to result in incorrect answers much, much more often. Once again, thank you for watching the video. If you found this to be helpful, please take the time to like and subscribe. Leave me a comment in the comment section and turn on the notifications so you can follow along with us as we're learning math together. One last thought. Dr. Seuss says, "Why fit in when you were born to stand out? You were born to be outstanding." So, make every effort to live that out, to be special, to give your best and contribute what you have to offer to the world. Best of luck to you. Thanks a lot. Take care.